Have you ever wondered why there is no life on Mars? We've all heard stories and watched movies about possible Martian civilizations, but the reality is quite different. In this video, we will explore the scientific reasons behind the absence of life on the red planet. Welcome to Section 1, Composition of Mars Atmosphere. Mars has a thin atmosphere primarily composed of carbon dioxide, unlike Earth. Additionally, it lacks a protective ozone layer and has minimal oxygen. This combination of factors makes the Martian atmosphere significantly different from Earth's, and these differences have profound implications for the potential existence of life on Mars. In the limited atmosphere of Mars, carbon dioxide dominates. It comprises about 95% of the Martian atmosphere, while other gases such as nitrogen and argon make up the remaining percentage. This stark contrast to Earth's atmosphere, where nitrogen and oxygen are the primary components, sets Mars apart. Furthermore, Mars lacks a protective ozone layer like the one found on Earth. The ozone layer shields our planet from harmful ultraviolet radiation coming from the sun. Without this shield, Mars is more susceptible to the damaging effects of UV radiation. Additionally, the Martian atmosphere has very little oxygen, which is essential for various biological processes on Earth. The scarcity of oxygen on Mars further limits the possibility of supporting life as we know it. Welcome to Section 2, Impact on Liquid Water. The thin atmosphere on Mars has significant consequences for the existence of liquid water on its surface. The low atmospheric pressure makes it extremely difficult for liquid water to form and remain stable. On Earth, the presence of a dense atmosphere allows water to exist in its liquid state, flowing in rivers, lakes, and oceans. However, the sparse atmosphere of Mars cannot exert enough pressure to keep water in a liquid form, leading to its rapid evaporation or freezing. The Martian surface poses numerous challenges for the existence of liquid water. The thin atmosphere on Mars leads to very low atmospheric pressure, which prevents water from remaining in a liquid state. When liquid water is exposed to the low-pressure conditions of the Martian surface, it readily evaporates into vapor or instantly freezes into ice. Without the presence of liquid water, a crucial ingredient for life as we know it, the chances of finding living organisms on Mars diminish significantly. Liquid water is essential for life as we know it. It serves as a universal solvent, facilitating chemical reactions necessary for the metabolism of living organisms. Water provides a medium for transporting nutrients, removing waste, and enabling the biochemical processes that sustain life. Without liquid water, the conditions required for the emergence and sustenance of life become incredibly challenging, if not impossible, to meet. Welcome to Section 3, Life as we know it. The presence of liquid water is intimately connected to the possibility of life. Water is not only a solvent for biological molecules but also plays a vital role in various metabolic processes. The absence of liquid water on Mars due to its thin atmosphere and extreme conditions greatly hampers the potential for life as we know it to exist on the planet. The presence of liquid water is crucial for the possibility of life as we know it. Water acts as a medium for vital chemical reactions, providing a suitable environment for the formation and functioning of biological molecules. It serves as a solvent for nutrients, enabling their transport and delivery to cells. The absence of liquid water on Mars severely limits the potential for the emergence and sustenance of life as we understand it. The thin atmosphere of Mars plays a significant role in hindering the formation of life on the planet. With its low atmospheric pressure, the thin atmosphere cannot retain heat efficiently, resulting in extreme temperature fluctuations on Mars. These extreme temperatures make it extremely challenging for life to survive or thrive. Moreover, the thin atmosphere offers little protection against harmful solar radiation, which can damage organic molecules and disrupt biological processes. This combination of factors makes it highly inhospitable for life as we know it to originate or sustain on Mars. Welcome to Section 1, Average Temperatures on Mars. Mars experiences extreme temperatures that make it inhospitable for life as we know it. The average temperatures on the red planet hover around -80 degrees Fahrenheit, -60 degrees Celsius. These extremely cold temperatures are far beyond the tolerance of most living organisms. It is essential to understand the impact of these extreme temperatures on the potential for life on Mars. Mars is known for its extreme temperatures, which greatly hinder the possibility of life on the planet. With average temperatures around -80 degrees Fahrenheit, -60 degrees Celsius, Mars is an extremely cold and inhospitable environment. These temperatures are beyond the tolerance of most forms of life as we know it. The extreme cold poses significant challenges to biological processes and the functioning of cellular systems. While some extremophiles on Earth have adapted to survive in extreme cold conditions, the harshness of the conditions on Mars is still too severe for even these hardy organisms. The average temperatures on Mars are exceptionally low, plunging to around -80 degrees Fahrenheit, -60 degrees Celsius. These extreme temperatures create an environment that is too cold to support most forms of life as we know it. The freezing cold on Mars poses numerous challenges for biological processes, leading to the inability of organisms to function and survive. The harsh conditions make it highly unlikely for complex life forms to exist on the red planet. Welcome to Section 2, Unsuitability for Life. The extreme temperatures experienced on Mars make it highly unsuitable for life as we know it. While some extremophiles on Earth have adapted to survive in extreme cold, the conditions on Mars are still too harsh for most organisms to endure. The freezing temperatures can cause biological structures to freeze and become damaged, leading to the inability to perform essential life functions. Additionally, the lack of heat sources and the limited availability of energy further restrict the potential for life to thrive on Mars. The extreme temperatures on Mars make it too cold to support most forms of life. With average temperatures around -80 degrees Fahrenheit, -60 degrees Celsius, the conditions are incredibly harsh and inhospitable. These freezing temperatures pose significant challenges to the survival and functioning of organisms. The cold environment can lead to the freezing and damaging of biological structures, disrupting cellular processes and making it nearly impossible for life to thrive. While some organisms on Earth, known as extremophiles, have adapted to survive in extreme cold, the conditions on Mars are still far too severe for them to survive. The extreme temperatures on Mars exhibit a harshness that makes it incredibly challenging for life to survive. With average temperatures around -80 degrees Fahrenheit, -60 degrees Celsius, the environment is extremely cold and unforgiving. The harshness of these extreme temperatures can lead to the freezing and fracturing of materials, disrupting biological structures and impeding vital biochemical processes. Moreover, the lack of a stable heat source and the absence of a protective atmosphere on Mars exacerbate the harsh conditions, making it unsuitable for most forms of life as we know it. Welcome to Section 3, Extremophiles on Earth. While Mars' extreme temperatures are inhospitable for most life forms, some extremophiles on Earth have adapted to survive in extreme cold conditions. These remarkable organisms have developed unique biological mechanisms to withstand freezing temperatures, such as producing antifreeze proteins or entering dormant states. However, it is important to note that the conditions on Mars are still far more challenging than what these extremophiles encounter on Earth. The lack of a stable heat source, limited availability of resources, and the absence of a protective atmosphere make the Martian environment too harsh for even these specialized organisms to thrive. Some extremophiles on Earth have managed to adapt and survive in extreme cold environments. These remarkable organisms, known as cold-adapted extremophiles, have developed unique strategies to thrive under freezing temperatures. They have evolved specialized proteins, such as antifreeze proteins, that prevent ice crystal formation in their cells. Additionally, some extremophiles can enter a dormant state, effectively slowing down their metabolism and conserving energy during periods of extreme cold. While these cold-adapted extremophiles demonstrate the resilience of life, it is important to emphasize that the conditions on Mars are still too harsh for even these specialized organisms to sustain biological processes necessary for life as we know it. Despite the adaptability of certain extremophiles on Earth to survive in extreme cold, the conditions on Mars are still too harsh for life as we know it to flourish. While some organisms have developed unique mechanisms to withstand freezing temperatures, the challenges presented by Mars go beyond what these organisms can endure. Mars lacks a stable heat source, resulting in a frigid environment that inhibits biological processes. Additionally, the limited availability of resources and the absence of a protective atmosphere make it extremely challenging for organisms to obtain the necessary energy and nutrients for survival. Therefore, while extremophiles demonstrate the resilience of life on Earth, the conditions on Mars remain too severe for life to exist in a sustainable and thriving manner. Welcome to Section 1, Past Evidence of Liquid Water on Mars. Scientists have gathered compelling evidence that liquid water might have existed on the Martian surface in the past. Geological features such as ancient river valleys, dried-up lake beds, and mineral deposits that require water for their formation strongly indicate the presence of liquid water on Mars billions of years ago. The existence of liquid water is significant because water is a fundamental requirement for life as we know it. It plays a crucial role in various biological processes, including the formation and functioning of cells, as well as providing a solvent for essential chemical reactions. However, despite the potential existence of liquid water in Mars' past, the present-day surface of the planet is predominantly dry and arid. Indications of liquid water in the Martian past provide strong evidence for the possibility of a wetter and more habitable Mars billions of years ago. One significant piece of evidence is the presence of ancient river valleys on the Martian surface. These channels, resembling those formed by flowing water on Earth, suggest that liquid water once flowed across the planet, carving out intricate networks of river systems. In addition to river valleys, scientists have also identified dried-up lake beds or playa environments, which further suggest the presence of standing water in the past. The discovery of clay minerals and hydrated salts in certain regions of Mars provides further support for the hypothesis of a watery past. These minerals often form in the presence of liquid water and can provide valuable insights into the history of Martian water. Liquid water is of utmost significance for life as we know it. It serves as a fundamental requirement for the existence and sustenance of living organisms. Water plays a vital role in various biological processes, serving as a solvent for essential chemical reactions within cells and providing a medium for biochemical transformations. It is an integral part of many biological structures, such as cell membranes, and is crucial for maintaining their integrity and functionality. Water also acts as a medium for nutrient transport and waste removal in living organisms. Therefore, the presence of liquid water is one of the key factors that scientists look for when searching for habitable environments beyond Earth. The lack of abundant liquid water on Mars significantly decreases the chances of finding life on the planet. Welcome to Section 2, Present-Day Surface Conditions. The surface of Mars today is characterized by its dry and arid nature. Unlike Earth, where we find vast bodies of liquid water like oceans, lakes, and rivers, Mars lacks large amounts of visible liquid water. The thin atmosphere of Mars, composed mainly of carbon dioxide, does not support the existence of liquid water on the surface due to the low atmospheric pressure. Instead, any water present on Mars would mostly exist in the form of ice in the polar ice caps, as well as in the subsurface as permafrost. The dryness and aridity of the Martian surface make it inhospitable for organisms that rely on liquid water for their survival. The surface of Mars is known for its dry and arid conditions. Unlike Earth, where vast expanses of water exist in the form of oceans, lakes, and rivers, the Martian surface appears barren and devoid of visible liquid water. The thin atmosphere of Mars, composed primarily of carbon dioxide, plays a significant role in the lack of liquid water on the surface. The low atmospheric pressure on Mars prevents water from existing in a liquid state, as it would quickly evaporate or boil away due to the minimal atmospheric support. Instead, any water present on Mars is typically found as ice in the polar ice caps or trapped within subsurface reservoirs. This dry and arid nature of the Martian surface greatly limits the potential for habitats that support life as we know it. The lack of abundant liquid water on Mars is a significant factor in the unlikelihood of finding life on the planet. Water is essential for life as we know it, and its absence greatly limits the potential for habitability. While there is evidence to suggest that liquid water might have existed on the Martian surface in the past, the present-day Mars is predominantly dry and arid. Without a sufficient amount of liquid water, the necessary conditions for the emergence and sustenance of life become highly challenging. Liquid water provides a medium for biochemical reactions, acts as a solvent for essential molecules, and facilitates the transport of nutrients and waste products within living organisms. The scarcity of liquid water on Mars greatly decreases the chances of finding life as we know it. Welcome to Section 3, Impact on the Potential for Life. The lack of liquid water on Mars has a profound impact on the potential for life to exist on the planet. Water is a fundamental requirement for life, as it serves as a crucial solvent for biochemical reactions and provides an environment for the emergence and evolution of living organisms. Without accessible and abundant liquid water, the chances of finding life as we know it on Mars are greatly diminished. The absence of liquid water restricts the possibilities for complex biological processes to occur, such as metabolism, reproduction, and growth. Additionally, water plays a critical role in the cycling of nutrients and energy within ecosystems, which are vital for supporting and sustaining life. Therefore, the lack of liquid water on Mars significantly decreases the chances of finding thriving and self-sustaining life forms on the planet. Liquid water holds immense importance for life as we know it. It is a fundamental requirement for the existence and sustenance of living organisms. Water acts as a versatile solvent, facilitating countless biochemical reactions necessary for life to thrive. It provides a medium for various metabolic processes within cells, allowing the transport of nutrients, the removal of waste products, and the maintenance of homeostasis. Additionally, water plays a crucial role in the formation and stability of biological structures, such as cell membranes. These membranes are vital for separating the internal environment of a cell from its surroundings and are essential for cellular function. Water's unique properties, such as its high heat capacity, make it an efficient regulator of temperature, which is crucial for maintaining suitable conditions for life. Its presence on a planetary surface significantly increases the chances of finding habitable environments capable of supporting diverse forms of life. The lack of liquid water on Mars greatly decreases the chances of finding life on the planet. Water is a fundamental requirement for life as we know it, and its absence makes it extremely challenging for organisms to survive and thrive. While Mars may have had a wetter and more habitable past, the present-day surface conditions make it largely inhospitable. Life as we understand it relies on the presence of liquid water for critical biological processes, including nutrient uptake, waste removal, and reproduction. Without a sufficient and accessible source of liquid water, the potential for complex organisms to emerge and sustain themselves is severely limited. The dry and arid conditions on Mars, combined with the low atmospheric pressure, restrict the formation and stability of the necessary conditions for life to exist. Therefore, the decreased availability of liquid water on Mars significantly hinders the chances of finding thriving and diverse life forms on the planet. Welcome to Section 1, Mars exposure to high levels of radiation. Mars is subjected to high levels of harmful radiation from the Sun due to its unique characteristics. Unlike Earth, Mars has a thin atmosphere, which provides little protection against incoming solar radiation. Additionally, Mars lacks a global magnetic field, which on Earth plays a crucial role in shielding the planet's surface from harmful radiation. As a result, Mars' surface is directly exposed to high-energy particles and ultraviolet, UV, radiation from the Sun. These forms of radiation can cause significant damage to biological organisms by interfering with cellular processes and damaging DNA and other essential molecules. The combination of Mars' thin atmosphere and lack of a magnetic field creates a challenging environment for life to survive and thrive on its surface. Welcome to Section 2, Effects of Radiation on Martian Surface. The high levels of radiation on Mars have significant consequences for potential life forms. The radiation consists of energetic particles and harmful UV rays that can penetrate the thin atmosphere and reach the planet's surface. When exposed to this radiation, biological organisms are at risk of DNA damage and the disruption of essential molecules. DNA damage can result in genetic mutations, impairing the functioning and reproduction of life forms. Additionally, radiation can interfere with vital cellular processes, such as protein synthesis and metabolism, leading to cell death and overall dysfunction. The combination of damaging radiation and the harsh environmental conditions on Mars creates a formidable barrier for life to establish and flourish on its surface. These effects of radiation make it challenging for any potential organisms to survive and thrive in such an inhospitable environment. Welcome to Section 3, Implications for the Existence of Life on Mars. The high levels of radiation on Mars have profound implications for the potential existence of life on the planet. Life, as we understand it, is based on the stability and integrity of genetic material, such as DNA. However, the damaging effects of radiation can disrupt and mutate DNA, making it difficult for organisms to maintain their genetic information and pass it on to future generations. Additionally, radiation can harm essential molecules involved in cellular functioning, further hindering the survival and development of life. The combination of Mars' exposure to high levels of harmful radiation, its thin atmosphere, and the absence of a global magnetic field significantly decreases the likelihood of finding thriving and complex life forms on the Martian surface. The harsh radiation environment poses a substantial barrier to the emergence and persistence of life on Mars. Welcome to Section 1, Thin Atmosphere. One of the primary challenges for life on Mars is its thin atmosphere. Compared to Earth, the Martian atmosphere is much less dense, composed primarily of carbon dioxide. This thin atmosphere offers minimal protection against external factors, such as harmful radiation from the sun and micrometeorite bombardment. The reduced atmospheric pressure also contributes to the low temperatures experienced on Mars, as it affects heat retention and distribution. Furthermore, the thin atmosphere makes it difficult for liquid water to exist in a stable, liquid state on the Martian surface. It prevents the formation of substantial bodies of water, such as oceans and lakes. The lack of a thick atmosphere on Mars creates an inhospitable environment, making it extremely challenging for life as we know it to survive and thrive. Welcome to Section 2, Extreme Temperatures. Mars has extreme temperatures that further contribute to its hostile environment. The average temperature on Mars is much colder than on Earth, with temperatures dropping well below freezing. At its warmest, near the equator during the summer, the temperature can reach about 70 degrees Fahrenheit, 20 degrees Celsius. However, during the Martian winters, temperatures can plummet to -195 degrees Fahrenheit, -125 degrees Celsius, in some regions. These extreme temperature variations create a challenging environment for any potential life forms to survive. The thin atmosphere of Mars also fails to efficiently retain heat, resulting in a rapid loss of warmth and making it difficult for organisms to maintain stable internal temperatures. The wide temperature swings and overall cold conditions make Mars an inhospitable place for life as we know it to thrive and flourish. Welcome to Section 3, Lack of liquid water and high radiation levels. The combination of the lack of liquid water and high radiation levels on Mars further contributes to its hostile environment. The absence of accessible and abundant liquid water significantly decreases the chances of finding thriving life forms on Mars. Additionally, Mars is exposed to high levels of harmful radiation from the sun, which can damage DNA and other essential molecules, making it challenging for life to survive and thrive on the Martian surface. The lack of liquid water and the presence of high radiation levels make Mars an inhospitable place for life as we know it to exist. In conclusion, while the search for extraterrestrial life continues, it seems highly unlikely that we will find life as we know it on Mars. The planet's limited atmosphere, extreme temperatures, lack of liquid water, high levels of radiation, and hostile environment make it extremely challenging for any form of life to survive. However, Mars still holds many mysteries waiting to be uncovered, and future missions and discoveries could potentially change our understanding. Until then, the question of life on Mars remains unanswered.